right. Right. I am not a musician. I wanted to talk to you a little bit about the art of applied science tonight. And now that phrase can have a couple of different meanings. The most obvious meaning would be perhaps the art of applying science for the purpose of solving a specific technical challenge or for solving a practical problem. That is widely known as the practice of engineering. That's my bread and butter. That's what I do to make a living, and that's what I've studied for many years. But it's the second meaning that I want to talk a little bit more about tonight, and that is the art that is created when science is applied as an expressive medium. But what is art? I mean, at what point how do you figure out the difference between art or an engineering project or a design project? Being an engineer, I like concise definitions that capture all cases of a given situation, so I decided to come up with a definition for art. It was pretty easy, it's just art after all. So I decided that art is any creative act or process intended to express or communicate an element of the universe that one person wants to share with another. In subsequent discussions about this particular definition, I conceded that the intent of sharing can be removed from that definition, because sometimes you just make art because you want it. It doesn't necessarily have to be for an audience. But essential to that definition, if you will, is the notion that it's a communicative effort. You're trying to express something. And any communication effort requires a medium. There are a lot of common media in the arts that a lot of people understand and are familiar with. You've got painters using color. You've got sculptors using texture and form to convey what's happening in their head. You've got musicians using sound, dancers using movement, and of course you've got writers and poets using syntax. So where does science fit into all of this? You know, science usually is not associated with art per se, not as a medium. The purvey of science is to understand the universe, is to describe how the universe works in a useful and repeatable way so that you can do stuff with it, like apply it, like be an engineer. And in that sense, I consider science to be somewhat the language of the universe. It may not be right. Theories evolve, theories get displaced, theories get improved upon. But if you take as a basis for this discussion that science is a language and it describes the way the universe works, then like any good, rich language, it's going to have a variety of dialects. It's got geology, chemistry, biology. My dialect is physics. I studied it for 6 years during my 4-year engineering degree. And I've actually been studying the dialect of physics since I could use my thumbs, smashing pieces of Lego with hammers, squishing bugs, riding bikes. Every object I picked up, every piece of clay I sculpted was actually an exploration into how the universe works and how physical objects behave. And if you consider the dialect to be physics, then the language obeys a certain set of rules, like grammar. The laws of physics are like the grammar of the universe. It governs how things interact when they get close to each other. Do you conjugate this way? What's the correct tense? If you don't follow the laws of grammar, you end up with gibberish. If you don't follow the laws of physics, you end up with, I don't know, a black hole or a machine that doesn't work. You can break that down even further. You can consider the materials that we work with to be an alphabet. You know, the sort of minimum constituent parts to the world that we work with, to the physical objects at least, and this is speaking from a mechanical engineering point of view, so keep in mind, don't get too philosophical on me here. I'm talking about objects, metal, rubber, glue, plastic. These are like the alphabet of the engineer. These are like the alphabet of the applied scientist, and you have to assemble these constituent parts into useful things that make sense, like words. And words are like components. So you could assemble letters into something that may be phonetically meaningful, like a CAPTCHA that you can pronounce, but it has no actual meaning. The practice of applying science to create machines that work requires you to assemble these materials in ways that are functional. And those functional assemblies of materials are components. And then when you bring components together under the guise, or under the laws of physics, under your grammatical structure, you can actually formulate sentences and tell stories and convey ideas. And those are what I call machines. The machines essentially express the poetry of the universe. They convey the very essential laws that govern everything that we touch and see into a physical manifestation that is derived according to some idea I have in my head. Here's a picture of me standing on my latest poem. It's called Prosthesis, Phase Alpha. You may be wondering what on earth phase alpha means, or what on earth I'm standing on. That is something that I designed. It's actually a partially complete version of something I designed. It's a 2/3 scale prototype leg. It's going to be used for testing and training and engineering development for my next art project, which is Prosthesis, the anti-robot, as Danny alluded to. Prosthesis is a 2-story tall, 4-legged wearable walking machine. It has no autonomy. It has no automatic controls, no active control system. The operation of this machine is completely dependent upon the skill of the user. Like I said, it stands 2 stories tall, and the user is strapped in the middle, sitting on a bicycle seat. Actually, it's a unicycle seat, because your legs have to swing in all directions, because you're strapped in on a 5-point harness, and your 4 limbs are going to be attached to an exoskeletal interface, which is going to engage your entire body, and you're going to be responsible for controlling the 4 limbs of this machine. The movements of your legs and arms will be mapped to that machine's 4 limbs, and there's a haptic feedback system that returns the position of those 4 limbs to your body. You can't see those limbs. You're 2 stories up, freaking out, wondering about what you're about to crush. And so you have to learn this machine, you have to feel this machine, you have to engage yourself entirely. It's been engineered for a top speed of 25 kilometers an hour, which is pretty freaky when you're 2 stories up. It's entirely dependent on the skill and the conditioning and the training and the sheer madness of the pilot. You can see there that the yellow dude is moving his arms and legs in conjunction with the machine. This is not a practical machine. You don't want to be a beginner on this machine, and that's why I'm building Phase Alpha, because I'm going to need some practice before I jump in this thing. It is an art project, and that's kind of the point. It carries no weaponry. This would be a terrible machine in the battlefield. You could take it out with a Honda Civic. You know, like it's 5 meters tall, and it's like a sports machine. It would be like taking an F1 car to Kandahar. And, you know, it's fast, and it's high-tech. No, but it's not a machine of war. Nor is it a machine for rehabilitation. You do not want to put anyone who is injured in this machine. You want to be fit and ready, and you want to have spent some time on Phase Alpha before you get in this bad boy, because you have to use your entire body. I'm actually not sure it's going to be possible, to be honest, but man, I'm going to try. And it is not for performing any specific task. This will not make you better at anything, unless being awesome and horrifying and totally, like, ominous is your goal. Like, this is not the Aliens loader with the, you know, you can't kill an alien or lift a load. The best you can do is reach 25 kilometers an hour without dying. And that brings us back to what makes this an art project. It's not intended to solve a problem. I'm not applying science to come up with a cure for cancer or create a new kind of material managing system. It is intended specifically to aid in the pursuit of physical mastery, to explore and revel in that process that people go through when they're internalizing a new skill. When you're riding your bike for the first time and you realize that your dad's let go of the seat, or when the transition you go through when you go from playing the notes to playing the music, when you link your first set of snowboard turns, that stunning, engaging process of committing your body and your mind to something and having to learn it on pain of death in this case. And by that, I want to expand the entire human experience. This is something that nobody has ever experienced before. This is something that will blow minds in ways that have not been blown before. And I want to do it by using science. I want to use what I've learned in my school and my education, and through all of the work I've done messing around, breaking toasters and burning my fingers, learning to weld. And the very rules that govern the operation of your own body, the rules of physics that govern you as a physical entity, also govern all of the machines around us. And this machine, this art project, seeks to unite the human being with the technology that we constantly create and are so constantly embattled against. And punchline, that allows you to commune with the universe in a way that we've never experienced before. Through this machine, through learning how to operate this machine. And if that's not art, I don't know what is. Thank you.